If we're planning a zero downtime migration, the first thing is to assume the old and new schemas have to coexist longer than we want. Additive changes first, then backfill, then switch reads, and only after that remove the old path. Otherwise, you end up doing the database equivalent of changing a tire while the car is moving.
People always say that like it's obvious, and then they try to rename a column in one shot.
Exactly. The safest pattern is expand, migrate, contract. For example, add the new column. Write to both old and new for a while, verify the data, then move reads over behind a feature flag. If the backfill is large, batch it and keep it idempotent.
Idempotent feels like the word everyone uses when they're nervous.
Usually for good reason. Also, avoid long locks. Some teams forget that a simple altered table can block everything if the table is big enough. We should check the specific database behavior before the release. I've seen a migration stall for 20 minutes because someone assumed rename meant free.
That sounds like a very expensive joke.
The rehearsals here are less chaotic than some deploys I've been part of, which is saying something.
The director just told them to find the truth in the scene, which feels uncomfortably similar to schema reviews.
We should do the same with data assumptions. Audit what's actually in production before writing the migration, because the code you think is there, and the code that's there are often different things. Backward compatible changes are really the foundation of all of this. If the old app version can still run against the new schema, deployment gets a lot less fragile.
Unless someone sneaks in a small breaking change and calls it temporary.
Right. A change is backward compatible if old readers can ignore the new data, and old writers can still insert valid rows. That usually means default values, nullable additions, new tables instead of mutating the old ones, and avoiding destructive changes until every consumer has moved.
So no, we'll just drop the column later as a plan?
Only as a final step after monitoring. And even then, I'd want usage metrics, logs, maybe a full release cycle where nothing touches it. It's boring, but boring is the goal. The best migration is the one nobody notices.
That's annoyingly true. I always want the neat version where the schema is cleaner immediately.
Me too. But the clean version can wait. Compatibility buys us time, and time is what lets us catch the weird edge cases before they turn into a 2 a.m. incident. Which is why versioning matters so much. If we version the schema changes and the app deploy together, we can tell exactly which combinations are supported, instead of hoping for the best.
And rollback?
Rollback has to be designed up front. The trap is assuming you can just revert the migration. Sometimes you can't, especially if you've already transformed data. So the safer strategy is to make forward fixes possible, keep old code paths alive long enough, and use reversible migrations only where they're truly reversible.
Though rollback is often really move forward carefully.
Pretty much. For dangerous changes, I like a fallback plan that's operational, not magical. Feature flags, dual writes, shadow reads, and a clear way to stop the rollout if error rates spike. If needed, we can route traffic back to the old version while the new schema sits there unused.
That sounds better than crossing fingers and refreshing dashboards like a superstition.
I've done that, and it does not improve the data. Ideally, we keep migration scripts versioned alongside the application, so we know exactly what was applied and when. Then, if the director here can keep 3 actors from speaking over each other, maybe we can keep 2 services from doing it too. Backfills are where a lot of simple migrations get interesting. The schema change itself is usually fine. It's the data movement that hurts.
Because that's when you find out the table isn't small.
Exactly. I'd keep backfills incremental, chunked by primary key or time range, and make each chunk retriable. Also, they should be throttled so we don't compete with live traffic. If the system starts to lag, pause, measure, Continue.
And if the data is messy?
Then the backfill has to be defensive. Validate before writing, log bad rows, and decide what to do with partial failures ahead of time. Don't let one malformed record stop the whole job, unless that's actually the correct business rule.
People love discovering correct business rules in the middle of an incident.
Unfortunately, yes. I'd also separate the backfill from the deploy if possible. That way we can observe the effect independently. It's much easier to debug when you know whether the issue came from the new code or from the data migration itself.
So 2 moving parts instead of one giant mystery.
Exactly. One mystery at a time is plenty. Coordinating app and database deploys is mostly about reducing the window where versions disagree. If the app expects the new schema too early, or the database changes before the app is ready, you get those lovely works on one node, fails on another, problems.
Lovely in the worst possible way.
The cleanest approach is usually deploy the backward-compatible database change first, then roll out the app that can handle both versions, and only then finish the contract phase. If we have multiple services, we need to know which ones read or write the same tables. Otherwise, someone on another team becomes the unexpected test case.
That sounds familiar. Rehearsal just got cut off because one actor came in on the wrong line, and suddenly everyone was pretending it was intentional.
Exactly the same feeling. We should coordinate release order, communicate the expected intermediate states, and maybe freeze unrelated changes during the critical window. The smaller the blast radius, the better.
And if something slips?
Then the safest thing is usually to keep compatibility, not rush the cleanup. Cleanup is attractive, but it's rarely urgent compared with keeping the system alive.